This is my lab 5 for DSF. This is our simulated lab. And so essentially the way that I looked at the lab was that though we had 5 different inputs, I looked at cell 1 and cell 0 as being like a type of different input from A, B, and C. And so that's why they're up here. Each different state or each different scenario for cell 1 and cell 0 that dictates a different equation for y and a different equation for C out. And the outputs for y and C out are determined by the inputs A, B, and C. And so essentially, for each state determined by the inputs of cell 1 and cell 0, I just have an AND gate where one input is whether or not it's the current state for cell 1 and cell 0, as seen here for these inputs, for these final layer of AND gates for y, and same for the final layer of ANDs for C out, as seen here. And so I'll go through the example for cell 1 and cell 0 being 0, 0. Whenever that's the case, the circuit that corresponds to the equation for y would be A or B or C in, and for C out, the equation would be AB or C in and XOR AB. So we have that circuit here. And so these circuits, these equations for y and C out depend on ABC, and so their input goes into the AND gate. But for this AND gate to evaluate to 1, it's not just dependent on A, B, and C. It also depends on the desired state for cell 1 and cell 0, dictating that that is in fact the equation for y or C out. And so we have 0, 1, and this output feeds into an AND gate for the specific state and for that equation for y, which would be NAND AB. And then for 1, 0 for y, we have X NOR AB, and for 1, 1 we have NOR AB for y. And so then this final layer of AND gates, it's just ORed to yield y. Same with C out. For the combination 0, 1, we would have AND AB for C out. We have XOR AB for whenever cell 1 and cell 0 are 1, 0. And then for the combination 1, 1, we have OR AB as the equation for C out. And it follows the same layout as the Y circuits up here. So this is the truth table I made for the schematic before implementing the circuit. And so let's see that the circuit has been implemented correctly and has the desired truth table. So I've labeled the different inputs and the different outputs. And so you can just look at it state by state. And so we see here that whenever cell 1 and cell 0 are 0, 0, we have the desired truth table as indicated in the Excel sheet and in Logisim. So for the next state, 0, 1, for NAND AB and AND AB, we have the desired truth table, which is determined by cell 1 and cell 0, and also A, B, and C. Kind of like after you've already evaluated cell 1 and cell 0, you evaluate y and C out. And then for the third state, you have the desired truth table, X NOR AB and XOR AB. And then for the final state, 1, 1, we have NOR AB and OR AB for Y and C out respectively, and we get the correct truth table. So, thank you.